So yesterday we talked about identity for cosine of difference of angles. We said cosine of, say, alpha minus beta. What was that? Cosine of alpha, cosine of beta, and then sine of alpha, sine of beta. We learned how to use it. We used it to get sine and cosine, or cosine of some new angles exactly. And we have a bit of a practice of what this thing means. Next level is to ask ourselves, where does this formula come from? So in mathematics, understanding the reasoning behind the formulas is one level higher than being able to just duplicate them and use them in practice. So what we want to do is to go a little bit higher up here and give a reasoning for this. The proof I give is a bit different from the one that is in the text. To do this, I'm going to go ahead and first prove something called the Law of Cosines. And that's going to save us some time at the end of the semester. I can say I have already done this thing, so we save one lecture. Before I do Law of Cosine, let me do a quick review from College Algebra, make sure everybody on the same plane. Suppose I have 2 minus 5x and I ask you to square it. So this whole thing is based on Pythagorean Theorem, which itself is based on squaring a bunch of stuff. So we need a little bit of practice on squaring. What happens here when I square? So square of the first one, yes. The square of the second one, which is like minus 5x, I have to square it. And then something else. Let me change my mind. I may change this into a 3. So what is the second component? What is the last component?
Plus 2 times negative 5.
So what are we saying here? We are just squaring identity. If you have a minus b squared, square of the first, square of the second. In that act, the sign is going to get stripped, so b squared. And then twice the first and second. Twice the first and second. The second is showing with a negative sign. That is going to give you minus 2ab. So if I have the terms a bit more complicated than just a and b, we just go ahead and do the same thing. So 3 squared minus 5x squared. In that act, I realized that I'm going to get plus 25x squared. And twice the first and second. Twice, here's the first, here's the second. So when we boil all these things down, I have 9, 25x squared, and in between I have, what does it, minus 30x, and so on. Okay, so make sure you are comfortable with squaring that. Now, what is Law of Cosines? Law of Cosine starts by the following Pythagorean theorem. It says, okay, you learned back in the basic geometry class, if this is A, this is B, this is 90 degrees, and then we have a nice connection between A, B, C, which is what? A squared plus B squared is equal to C squared. So if this is a right triangle, that's going to hold, and if that holds, there is a right triangle with the legs AB and hypotenuse C. Question comes up. What if you were not so lucky as to get a right triangle? What if it was something else? What are you going to do then? So Law of Cosines is the answer to that question. If I have a triangle, this is A, this is B, but this is some arbitrary angle theta. What can I say about C? Who is C now? Law of Cosines, we are going to proceed to show that something like that gets started, but there is a correction depending on this angle, which is minus 2ab cosine of theta. That is going to be C squared. So Law of Cosine means that. Well, where does that come from? It really comes from a couple of applications of Pythagorean Theorem plus a bit of practice on from algebra. How do I proceed? Let me redraw my picture so that I have room to draw additional. So this is my A, this is my B. I go ahead and, as is magic of geometry, how do you split things up? I draw a line. Let's call this this is altitude, typically shown by letter H. Then I separate my pieces here, call this thing perhaps X, and call the other one Y. Our angle is still same old starting angle. This is our angle theta. Now we are going to focus on each of these right triangles, and from those right triangles we are going to extract the information that we need. First, the left triangle, I have this right triangle. This is A, this is theta, this is H, this is X. I want to get my H and X out of A and theta. A and theta are primarily given at the beginning. These are things I'm just making up to go ahead. So first, connect these three things to me. Tell me a formula that connects A, theta, and X. What is a connection? Tell me, like, what is X? X is adjacent to theta, so we have practiced this thing a few times. What is it in terms of A and theta? A cosine theta. Very good. How about doing this thing again, but this time with respect to A, this theta, and this H? What is my H equal to? Very good. Now, I have my X. Let me write it here maybe. This is A cosine theta. I got my H. That is my A sine theta. Who's going to be Y? Now I ask, how about Y? Well, if this whole thing was B, and this part of it is X, then what's left for Y? Give me Y in terms of B and X. B minus X, which is, as you mentioned, well, X is that A cosine theta, so that's really B minus A cosine theta. Now we come and focus on this longer right triangle on the right side. Here I have my pieces. Remember, our original aim was to catch this C. That's what I want. I want this C. I know this is Y. I know this is H. So what does the Pythagorean theorem tell me as a connection between H, Y, and C? How do I get C squared? C squared is equal to?
Y squared plus H squared.
Yeah, very good. Now all we have to do is to take H and Y from what we have here, plug it back here, do the squaring, and do a cleanup. That's all. So I go ahead. You help me out here. Instead of H, what should I write? A sine theta. That whole thing has to be squared. Instead of Y, what should I write? E minus A cosine theta. That has to be squared. Then that is going to be C squared by the Pythagorean theorem. Now I go ahead, do the squaring. Something times something else squared. So that is A first item squared and then second item squared. I go ahead. This squaring, the reason I took you through this practice so that you'll be feeling a bit more comfortable to square this one. Square of the first. Now you help me out with the next item. What's the next item? minus a squared. Is that all? Well, this is the whole thing. Minus a cosine of theta squared. Is that right? Just like here, we had minus 5x. I had to take minus 5x, and the whole thing had to be squared. And of course, later we cleaned it up. But this is one term. That's minus 5x. That's our second piece here. That's like minus b here. That whole thing has to be squared. Now, what else is missing? 2 times the first times the second. Is that right? It's a little bit complicated, but, well, that's the nature of the beast. So, on the right-hand side is going to be c squared. So, what I did here, this was an attempt to open this up. That needs a practice in college algebra to do that quickly and confidently. Now, if we go ahead, clean up some more. You said, okay, this is a squared. Traditionally, 2 is written on top of the name of the function. What we understand, of course, you get the value and then square it. This is a b squared. During squaring, minus evaporates, of course. This is a squared. Cosine theta squared is written like this. And plus 2b times minus a, I can write it in a more civilized way as minus 2ab, and then I also have cosine theta. By Pythagorean theorem, that's going to be hypotenuse squared. Well, what do you think I'm going to talk about next? What's going to happen? What simplification is going to show up next? Who matches to this guy? There is somebody that matches this guy to simplify, which is? Which term here is a... Very good. Here's the... I said this is for the education majors. So the one that matches this thing is a squared. And so I write them next to each other. A squared sine square of theta, and then a squared cosine square of theta, plus b squared, I just wrote it next, and then minus 2ab cosine theta is equal to c squared. Now, what am I going to do to these two? What was the purpose of this? What do we do? I can factor a squared out of it. Is that right? A squared times sine square of theta plus cosine square of theta. I have b squared minus 2ab cosine theta. So what is this parenthesis? Just 1. So what are we left with? A squared plus b squared minus 2ab cosine theta is equal to c squared. This is that famous law of cosines. It's a cornerstone of all triangulation they do in business to find the length of things. That is important. So that's called the law. Yes, question.
What section is this technically?
That is a redoing of 2.1. If you look at section 2.1, you see at the beginning there are those unit circles drawn on page 108. What I am doing is I am bypassing that. Instead of doing that, I am doing the section, instead of that, I am doing section 3.2. So if you go, you find this in section 3.2. Part of your syllabus is to learn that. So we are saving time by bringing that lecture here, which is going to do 2 jobs for us. One is by itself is important. The second is going to be used to justify, let's not forget what is it that we are after. We are trying to justify this rule. Where does this thing come from? peculiar thing. We just pulled out of the hat. We said this is true. And a good student will always object, why is that true? So what we have gone through one stage. This requires two stages to get there. I have gone through one stage. One stage is to show you this law of cosines, and just to make sure we all understand it, let's go ahead and practice it in the context of one example. And then we are going to come back to the remainder of that lecture. I think, let me guess, since I've had 10,000 students, you are going to be asking me if that's going to be on the exam.
Yes.
Yes.
Like class study 3.1 and then 3.2?
No, missing a lot of points here, but as I said, this is for the education majors, so that when they go back to their classes, they tell the class, look, we need to find the truth of the statements that we make. We are not here just to memorize formulas and this and that. We are trying to understand things. I could have gone through the proof of section 2.1 and asked you exact same thing. It's not going to be any easier. So I knew last night I was playing the movie in my head. He's going to ask, is that going to be on the exam? I knew that 24 hours in advance. So I said, what can I say? So it's kind of, well, anyway, once you become a teacher, you will know. So anyway, this is for 3.2. You're not planning, I guess. Huh?
I don't like kids.
Oh. But you were a kid yourself.
I don't think I was.
That's why he doesn't like them.
Yeah. If I meet any like I was when I was a kid, I wouldn't like them.
Oh, I see. Okay. Well, maybe your perspective will change. Anyway, what we are doing is, once again, this is, of course, this is like icing on the cake. Is a little bit more than what everything stuff you have done. Try to absorb as much of it as you can, and if it is going a little bit over the top, put it for the second reading. Let's move ahead and do one practice. As I mentioned, you could be getting a job with a geotechnical institute somewhere, and you do field measurements. You are going to do stuff related to what we are talking about. Suppose you have measured one side of a road. This is, say, 10 miles long, and there is another road here, and that is, say, 7 miles long, and the angle here happens to be, say, 60 degrees. What we want to do is to find out how long the road is going to be if it goes from here straight to this point. That's the question. Either because the road is not there, or maybe there is an obstacle in between, a mountain or something. You want to find out the distance between these two. So again, trigonometry is the art of measuring things that might not be easily accessible. The question is, how do you get this? Let's call them by A, B, C. A, B, C here. What do I say? Say C squared is equal to A squared plus B squared minus 2AB cosine of theta. So I just go ahead and say my A is 10 miles. 10 miles squared. This is 7 miles squared minus 2 times 10 times 7 times cosine of 60. So our job is just reduce the plugging numbers in, and we'll be all set. 149. Well, this is 140. What's cosine of 60? By now we are quick on that. Is that right? Cosine of 60. How do we quickly get it? It says 60. If this is 30, goes to as 2, 1 radical 3. Cosine of 60 is 1/2. Is that right? So 149 minus 70 makes it 79. So the distance from this spot to that spot is going to be what? Square root of 79, about 9 miles. So we find out that the distance is about so 8 point what? You use.
What are the symbols behind the 10 and the 7? What is that?
This is the, previously we had called these legs A and B, so I'm just trying to say this was my A, this is my B, that is the theta in between. So this length, your B is 7, your A is 10, your theta is 60 in this formula. So we kind of go ahead like the Pythagorean theorem, that is you start with the square of this leg and square of the other leg, but of course when you are bringing this tip closer to that by bending it away from 90 degrees, that distance is going to get shortened. What is the correction? There is a nice formula for the correction. That's how much it's going to get shorter. Minus twice the product of the two legs times the cosine of the angle between the two of them. If you had left the angle at 90 degrees, that cosine would be 0. There is no correction to make. If you make it an acute angle, you have to subtract. If you open it the other way and make it obtuse angle, what is going to happen to C is going to get bigger because cosine becomes negative and your third leg becomes bigger. Okay, so that was step 1. Step 2, again, let me remind you something from College Algebra. In College Algebra, you have a so-called distance formula. Let me see if you remember that distance formula. That shows up in the proof of in the text quite a few times. Suppose you have a point at the location 3 and 2, and you have another location so I have two spots in the plane, and the question I ask is how far apart are they from each other? Again, a main preoccupation is to find distances. What do you do in college algebra to find the distances? Distance formula, which tells you to do what?
X squared minus x squared plus y squared, y2 squared minus y1 squared.
It was close, but you didn't read it right. You have to okay, let's understand where that formula itself comes from. Again, almost everything in elementary math comes from Pythagorean theorem. You make a right triangle. You find the legs. Once you have the legs, you find the hypotenuse. So how do I find this leg? The way I find this leg, I say I am starting at 3. When I say x coordinate 7, it means here I am at 7. How far apart are these two from each other? 7 minus 3 is 4. So that is the first piece of the formula you were reading. Difference of x's. Next, I ask the same kind of question on the y's. This, when you say this is 2, it means your height here is 2. When you say the second coordinate is 4, it means this location is 4. So you have gone from 2 to 4. Well, how much have you moved up? So 4 minus 2 is 2. So that is a justification for the second component of the formula. Subtract your y's. So now this, you know this is 4, you know this is 2. So you go ahead, you find the hypotenuse by Pythagorean theorem. Say take square root of 4 squared plus 2 squared. But let's go ahead. Let's see how we track everything. So 7 minus 3, difference of the x's squared. 4 minus 2. Who are 2, 4 and 2? Y's subtracted and squared. and that was going to give me 4 squared plus 2 squared, which is radical 20, and then I'm set. So the formula Peggy was reading was based on this. I have point number 1 is coordinates I'm calling x1, y1. I have point number 2. The coordinates of this one is x2, y2. I want to find the distance. The distance then, square root of, I do the same thing. So I've gone from x1 to x2. So I have moved by this much. This is one of the legs. Then I have the other leg, y2 minus y1. So let's color it. This is what this one is, and this is what this one is. So that's a practice on the distance formula. So again, let's remind ourselves, why are we putting ourselves through all this torture? We are trying to find a way to establish that. In higher mathematics, it's your job to actually establish that, to guess that and extract it. That's what you read out of the good book. You read it. But then you have to justify it to everybody else. Well, everybody else has gone through these prior steps. You cook up reasoning according to those to come up to that point. Let's see how. So just like any form of art that you have to be creative to do something, it's the same kind of a story here. Let's go back to the following kind of a situation. Suppose you have a triangle here, and this angle is, what did we use here? We used beta minus alpha, sorry. Alpha minus beta, sorry for that. Suppose this is angle beta. I draw another angle, call that, alpha. What would be this angle? Alpha minus beta. Now, suppose the length of each of these sides suppose I take this thing to be some length A, doesn't matter, and then I pick the same length here. Let me ask you a couple of questions. I draw the coordinate system. I draw this angle beta, and this distance I call it A. Tell me, what are the coordinates of this point? What do you mean coordinate? Coordinate means these things. Tell me the x and the y. What is the x, what is the y of this point? X is, of course, the adjacent to this angle beta. We have seen this quite a few times. What is going to be the formula for the x component? Let me make more room here. You said what? X is the adjacent, is A cosine beta. This is A cosine beta. How about the y component? A sine beta. So this point has coordinates A, how about this point? How is that any different? The opening angle of it is what? This red angle. Alpha, so same stories. A cosine alpha, A sine alpha. I made one tiny mistake. Let me go back and see how this was. I had A and B over there. Sorry for that. Let me okay. Let me just change the length of one of the legs. Just tiny. So that it's not misleading. Call this thing B. I use the same letter, all of them. Okay, so one of them is A, one of them is B. Same story as before. Now we do one or two things. One is that I ask you what is the distance of these 2 points. Okay, call that C. We do it 2 ways. Find C first by distance formula. Two, by law of cosines. Since the distance has to be same either way, when we set the 2 answers equal to each other, we get what we have been working so hard for. By distance formula, we said if we want to find distance of 2 points, what do we do with the coordinates? Here's it. If you want to find distance of 2 points, you do that. So what should I do with the coordinates? Tell me. Somebody read it out to me. What should I write?
Are you using the same XY format with that?
Yes. You remember to get the distance? Here, let me show you again. This was our distance formula. Let's understand the essence of it. What was it? Difference of the x coordinates squared plus difference of y coordinates squared. That was just a Pythagorean formula. Now we are applying it to this case. My coordinates are a little bit more complicated, but there are still coordinates. So what do I do with them? Very good. B cosine beta. Excellent. A cosine alpha. That is difference of these 2 x's. That's the one leg. I get the leg and square it. And then I have a second piece. What's my second piece? Okay. We have to figure that out. It looks a bit scary, but we can do it. We are doing. Law of cosines. Law of cosine tell me what? Law of cosine all the way up here. So if I have a triangle with the legs A and B and some angle between the 2 of them, then third side is A squared plus B squared minus 2AB times the cosine of angle between the 2. So whatever the angle is, I get square of this, square of that, minus twice AB cosine of that angle. That's going to give me my third side. So I come here and do the same thing. So I have a second way of doing this thing. One leg is A, one leg is B. The angle between the two of them is alpha minus beta. So I say A squared plus B squared. Now help me out with that. What is left? Minus
2AB
cosine of alpha minus beta. Is that right? Cosine of the angle between the two of them. This is our new theta. Theta is alpha minus beta. Well, it doesn't make a difference what your, this is alpha, this is beta, the difference is alpha minus beta, but cosine of an angle and cosine of a negative of it are the same anyway. Even if you wrote beta minus alpha, it would be same as this. Okay, what we have to do is to clean this up. That's going to take a bit of algebra and then make it equal to this and see what we get. So bear with me while I do this. You help me out. C squared. We had that squaring practice. Let's see that helps us here to do this thing quickly and correctly. Help me with squaring this expression. I have square of the first, which is b squared times cosine square of beta. We practiced this thing before. Is that right? Then I have square of the second guy. Tell me what is that? Plus a squared, then what else? Cosine square of alpha. And then that we had important cross term. What is that cross term here? You remember when we were squaring all the way up here? We have square of the first, square of the second, and then we have some important other term. Twice the first and second. Remember that? When you have a minus b squared, a squared plus b squared minus 2ab. I'm asking you to not to forget that last term. So first squared, second squared, and then minus, write it nicely, first times the second. We multiply a and b, cosine of alpha, cosine beta. Is that right? Twice. The first and second, I put up front, A's and B's, I put them up front. I put the cosines next to each other because that way it looks nicer. Otherwise, it's B cosine beta times A cosine alpha times a minus 2, which is same as this. Okay, so far we have done half of the job. This is this one. Now we have to handle the second piece. How about this guy? But we got our lesson. It's going to be just like that. Let's continue. You help me out with that portion as well. Let's read that quickly. What is the first piece? B squared sine square of beta. Next. Yeah, either way. Obviously, we have another education major here who is following all the algebra. Is that right? Are you education major?
Yeah.
My guessing is good. But maybe you're an engineer. Okay, okay, you still need to help me. How do I clean up this mess? It's lots of stuff here. Combine things that look like they are twins or something. So who is the twin of b squared cosine square of beta? B squared sine square of beta. When you add them, can you just add them in your mind and tell me what that is? So this problem doesn't look as bad as our friend was saying. It's just b squared. How about this? Who is the companion of that one? Okay, these two go hand in hand, and the net of that is just a squared. How about the remainder? The only thing they have in common is that minus 2ab. So I write minus 2ab, put everything else in a parenthesis. Cosine alpha, cosine beta. You see the light? Sine alpha, sine beta. So that was c squared by distance formula. But there is also c squared by law of cosine, which is a squared plus b squared minus 2ab cosine of alpha minus beta. Now when we stare at the both sides, we conclude what? That this expression has to be same as that. Everything else is the same. A squared is a squared. B squared, I got a b squared. Multiple minus 2ab, I got multiple minus 2ab. So these two things have to be the same, and that is our holy grail here. We got this. We got cosine of alpha minus beta is really cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Okay? So, yes, it was painful to get here. So, yes, it is a struggle. But that is the beauty of mathematics, that you can show to somebody else, look, I went step by step. You can check every step I did, and at the end of it, you agree with me that this is so. So mathematics is then built by consensus. Everybody who wants to check it is going to check it. If you have objection to any of it, you can raise it. Otherwise, it's going to be recorded there as true. And once it is there, 99.99% of cases, then it is true. There have been cases that somebody said something and somebody else found that it was wrong 20 years later. But with much higher certainty than any other field, we can say this is so. So this is so. That is cosine of a difference of angles. And then all sorts of other identities can be built out of it. We went through some of them last time. Let's take a break, and then we go back to our regularly scheduled program to something that is simpler. And for those of you who are concerned about this, of course I cannot ask you to do this thing on a test. It already took me 40 minutes, so that cannot be on the test. But you want to understand what it is and hopefully explain it to your own students. Okay, so let's take 2 minutes.